Hi and welcome back to another LeetCode video. Today we're tackling LeetCode 528, random pick with weight. And in this video I'm going to show you how to solve this problem optimally. There's a nice trick to this, which you should probably remember, as this is actually one of the questions that you can get asked in an actual interview. So, well, what are we dealing with? Well, first of all, we need to implement a function pickIndex, which randomly picks an index in the range between 0 and the length of an array that we get passed into our constructor. Now, the kick is that the weights array that we receive contains different weights for each of the indices that allows us to compute the probability of picking a specific index. And there's a formula here for how do you determine this probability. And it is the weight at the position divided by the sum of all of the weights. So if you have the numbers, and let's go here. So if you have the numbers, let's say 1 and 3, the sum of them is 4. So the probability for picking the number at index 0 is 1 over 4, or 25%. The probability for picking the index 1 is 3 over 4, or 75%. So they add up to 100% in total. And the way to deal with that problem is, if you want a weighted probability distribution, not just a homogeneous one where all indices are picked with the same probability, you need to somehow convert this into a different type of problem. And what we can do to solve this problem is we could build the prefix sum of all of the weights so that we get an array that tells us what is the probability that we're going to choose a value in that array up to that point. So let's say we have a very long array and we're going to populate it with some values. 1, 2, 3, 4, 5. So we need 5 values. Let's say 1, 3, 2, 1, and maybe 6. So the sum of this would be 10, 11, 12, 13, 14, if I'm not mistaken. Let's check. 10, no, 13, right? 6, 7, 8, 9, 10. So it's 13. The sum is 13. All right, 13. Now, if we build the prefix sum of all of these values, we would get a 1, we would get a 4, we would get a 6, a 7, and a 13, right? So now picking an index suddenly becomes a binary search problem, because we just need to generate a random number that is between the first value and the sum. And we could technically say between 1 and the sum, and then all we need to do is a binary search. So we pick a random number, let's say 5. So if our random number r equals 5, well, then we know if we start iterating through this array, we know that, well, we're not going to iterate, right? We're going to use binary search. So let's say this is our midpoint. So we have a left, we have a right, and then this will be our mid. Now we compare the 6 against our 5. 6 is larger than 5. So we have to go, well, we have to start to consider the left side of the array. And then we have a new mid, and then we end up at this node. So that means we're going to pick this particular value. And what we've now done at index 1, right? So this is still the indices. We still have them. They're the same as in the original array, 3 and 4. And yeah, and what we now return is the index of 1. So we've gotten from a random number that we generate, to finding the index position that we should pick, and using a weighted probability distribution. That's kind of the trick. That's all there is to that problem. It's kind of easy to implement as well. So all we need for that is, well, we need a prefix sum, and that's going to be an array. We also need to remember, what the total is. And we're going to initialize that with 0. And then we're just going to build the prefix sum array. Weight in W. And then all we do is we increase the total sum. And then we just append the total sum to our array. Cool. Now, the second part where we do the binary search, well, we need to pick a random number that we're going to try to find. So we will, or we don't have to use an import. We can just do it like this. So we could say a target is random.randint from 1 to self, the total sum, right? The prefix total, right? And yeah, and then we have to just implement a binary search. So I'll do it like this. So length of prefix sum -1, and then while left smaller equal right, compute the midpoint, that's left plus right divided by 2. Now we check if is self prefix sum at mid is larger or equal than the target value. We could, say this is a potential result because we're not expected to find an exact match. And we could update our result value here. Result value is, well, the index, which is just mid. And then we continue to find for a closer value in the left side of our prefix sum array. We say right equals mid -1. And the other case is where we have to adjust our left pointer, because it means we're going to continue to search in the right sub-array, to the right of mid. Right, and then we just return result. That should be everything. So let's run this code real quick. Expected colon, right? Let me see some, we're missing a dot append up here. And if we look at the runtime complexity, obviously the constructor is O of n time, and another typo here, the constructor is O of n time, and the picking is just log of n time. We're missing a self here. Let's see, do we miss any other self? No, we don't. Right, so pass the test cases. Now, I'm not 100% sure if we should update our result in this case, or if we should it when we construct the left side. So let's submit and find out. If this doesn't work, then it has to do with that. But it works out nicely. So cool. Okay. Right, so this concludes the solve of this problem. The trick really is to turn all of these random weights that have random values throughout the array into something that is an increasing, or, well, it's not strictly increasing, but it's increasing. At every index, we're going to increase the value that is here. And once we have an array that has increasing values in it, we can use a binary search. And that's the trick to solving this problem.